All right, hello once again. This is Jeff Scott from Jeff Teaches Programming. In the last video that I created, as you can see right here, we began talking about object-oriented programming, also known as OOP. All right, and we went through some of the stuff. I'm going to go through some more today. And we're going to first write our first object-oriented program here as well, or at least start to. All right. I found this is something that I went through the Microsoft, learnmicrosoft.com, .NET, C# fundamental tutorials on OOP, and this is what I gleaned out of it. We've talked about this a little bit before, and I'm just going to talk about it again here. All right? So, the four principles, also known as the pillars of object-oriented programming, are abstraction, encapsulation, inheritance, and polymorphism. Abstraction, basically, for lack of better words, we talked about this before, you only show the user what they need to get the job done. You don't show them how the job is getting done. You show them the interface, which is what they need. And if you remember the example that I gave, a very simple, primitive example, I brought up the calculator. I typed in a number like 347 and I hit the square root key. Now, my interface is that calculator and what I have to type in and press, etc. But the implementation that's hidden from me is how that 347 turns into the square root of 347. That's been abstracted from me, and I think I mentioned this before. On the off chance I did not, we live our lives in an abstracted way. All right? I'm sitting here in my living room right now, and there's a fireplace going. I don't know. It's a gas fireplace. I don't know exactly how that works. I know how to turn it on. I know how to turn it off. It's a very windy day, so hopefully I know how to restart the pilot light should it blow out. All right? So that's abstraction. Encapsulation goes hand in hand with this. As it says, it's hiding the functionality of an object, but only allowing you to access it through public methods. One thing I mentioned in the last video, giving a very simple, succinct definition of object-oriented programming. It's not totally complete, but it's using public methods to work with private data. Now, as I mentioned, you can't have public data, not recommended. You can have private functions, typically known as helper functions. All right? Then we have inheritance. As it says, it's able to create something new based on something that exists. In some ways, kind of like genetic inheritance, but in other ways, totally different. Finally, we have polymorphism. And that's basically the ability to have a method that has the same name throughout different classes or different whatever, and being able to, I use the example of having a speak method, having an animal class with a speak method, and then having a dog class, a cat class, and a bird class, and having each one of them have a speak method. Well, the dog.speak, or the instance of a dog, is going to be different than the cat.speak. It's going to be different than the bird.speak, etc. All right, so that's a little bit of a little reminder of what we talked about. All right, so with that said, I want to jump into this here. This is from .NET Interview Prep, Mastering Object-Oriented Programming in C#, A Beginner's Guide. This is going to sound a lot, at least somewhat similar, all right, somewhat similar to what we've already talked about. All right. So what is object-oriented programming? As it says, it's a paradigm. A paradigm is a shift in thought. All right? Everything we've been doing, I shouldn't even say that. Most of what we've been doing thus far has been working with things procedurally. But whether you realize it or not, you've been using classes throughout this course. For example, what we just did in the last series of programs that we created, we used the array class, right? And if we wanted to sort an array, we said array.source. Array is a class. Source is the method that can be used by that class in order to do something. All right. As it says, using an object-oriented approach keeps code modular, reusable, and scalable. And there's those concepts again: encapsulation, inheritance, polymorphism, and abstraction. So a class, as we mentioned before, is a blueprint. I use the example of a builder coming in and buying a big tract of land and creating, let's say, 100 houses on that tract of land, and having 5 different house plans where you'd go house 1, then 2, 3, 4, 5, then repeat it again, for example. Those 5 house plans are the blueprints for creating houses. Those would be 5 different house classes. Each house that was created from there would be an object. All right, as it says, classes define properties, and that's in here. I don't like this example because they make these fields public, which is not really recommended. All right, and in here we've got, there's a constructor, which is an example of a method. Here's another method. All right, objects again are instances of a class. The act of creating an object or objects from a class is called instantiation. All right. Encapsulation, as we mentioned, it's building the data and the methods that operate into a single unit, encapsulating everything in there. And they also talk about access. Now, we've talked a little bit about this before, but I want to mention it again. When something is public, you're making it available to anyone and everyone. When something is private, you're making it available only to where it's been defined. So, for instance, person now has a private string called name, and that private string called name is only available within this person class. If something is public, if we made it public, then other classes could use the name field. If something is protected, it's available not only within the class that creates it, but any class that inherits from that class. Speaking of which, as it says here, inheritance is the process by which one class, also known as a subclass or a derived class, can inherit fields, properties, and methods from another class called a base class. The subclass is also known as a child class. The base class is also known as a parent class. As it says, this allows you to create new classes based on existing ones. This allows you to keep up with the idea of code reuse and reducing redundancy. So here's an animal class. All right. And then we created a class dog. This means in C#, inherits from animal. So dog is an animal. So dog can bark, but notice dog can also eat. And if we wanted to or needed to, we could redefine the eat method inside of here as well. Finally, we have polymorphism. Polymorphism is a Greek term for many forms. And as it says, it allows one interface to be used for a general class of actions. So here you go. We mentioned this before. You've got sound that you've created inside of class animal, then you override it, which means that if for a dog calling sound, it's going to do a bark. It overrides the implementation of sound in the animal class. All right, and abstraction we've already talked about. Abstraction, as it says, stop that for a second. All right then, so to continue on and to finish up this discussion we've been having, again, abstraction hides the implementation details and shows only the essential features. The implementation is hidden. The essential features that are shown are the interface. All right, what's the difference between a class and an object? A class is a blueprint from which objects are made. An object is an instance of a class. What is an abstract class? An abstract class is one that can't be instantiated. So in the example we showed above here, we could use this one, but let's use this one here. If we'd said abstract there, that would mean you couldn't create an animal. You could create a dog because it's not abstract. So in this example, you can't create a shape, but you can create a circle. Abstract means it cannot be instantiated. Can a C class inherit from multiple classes? No, C does not support multiple inheritance. Another language similar to C, but not at all the same, really, C++ does allow multiple inheritance. What is method overloading? As it says, multiple methods with the same name exist, as long as they have different parameters. Method overriding is when you have typically a parent that defines a method and you redefine it in a child. That's overriding. Why is polymorphism important? As it says, it allows objects to be treated as instances of their parent class. All right, we'll continue our discussion of this stuff too. All right, but I think it's probably now, I think at least, it's a good time to go in and start actually creating something. So I'm going to go back. Where am I? Oh, I removed my... I thought I put 2026 on here. There we are. All right. So let's come in here and let's just bring this up. There is VS Code Copilot in here now. I'm not trying to do things using object orientation. All right. I want to do this stuff. I don't want this stuff done for me. That's just my opinion. You could totally disagree with it, and that's fine. All right. So I'm going to come in here, and I'm going to create in here 3 versions of a person class. And as you'd probably guess, each one will be a little bit more complex than the one before it. So we want a C#. In fact, we've got it here. No, we don't. Let's see. I'm trying to figure out the best way to do this. You know what I'm going to do? I am going to come in here and create a class library. All right. So I'm going to come in here and create a class library, and I'm going to call it person. All right, not the greatest name, but it'll work just fine. Okay, so this is my class library. All right, it doesn't know what I need. I don't really like, well, the namespace is person. Let's do this. I guess I wish I wouldn't have done what I just did, so I'm going to undo it. So let's just delete this. All right, I want to make sure that that's gone, so I'm going to come up here. And if I do have something still called person, which I do, I'm going to delete that as well. All right, so let's come in here. We'll create another class library. I'm going to call it people instead of person. All right, so there we got people. I'm going to change the name of the class. So I want to rename this. And I'm going to rename it person. All right, so I have a person, and it sounds stupid to say, but a person is a people kind of, so, but don't worry about that. All right, I'm going to start by creating some private fields. Now, what some people do, you don't have to, is I'm going to make a first name, a last name, a gender, and an age. I'm going to keep it simple. Now, I can come in here and say private string first name, private string last name, totally fine. Private int age, sure. And in fact, before we even do that, let's make the gender. The order in which you create these is, of course, totally up to you. So I'm going to do a private string gender and a private int age. All right. So what oftentimes people do to designate and show that these are private fields is they put an underscore in there. You don't have to do that. I've never been given a great explanation of why that's done. There's nothing wrong with doing it, and I am going to do it in here, so in the example that I'm using here. All right, so I've got all this. Now, let's make some public properties. And I actually, when I wrote this, I'm working off what I've already done. I did a little more than you typically would do. In other words, when I created these methods or these the stuff I'm doing, I actually set it up so there's some validation done as well. So we'll say here, public properties with validation added. Okay, so the first one is the first name. Now this is going to look a little funky. Let me do the whole thing here. All right, you'll notice that right away, all right, the what kicked in was the IntelliSense. All right, now you don't have to do what I'm doing right here, but I think it reads a little better when you do this, like that. And it looks like I'm missing a curly, so we'll put that one in. Oops, no, I'm wrong. All right, so that's a get, and then we're going to have a set as well. Oh boy. And it looks like, what am I missing here? All right, I'm going to leave this the way it is. This is all stuff the IntelliSense put in. All right, and I'll need to end my first name here. There. Now, absolutely nothing wrong with what I just did. This is a getter, which says return the first name. Get the first name. This is a setter. Now, value is basically whatever you end up passing in. All right, it's a key word, but I want to show you a couple things. First of all, this getter, totally fine the way it is. But I can also write this as just one line. I'm going to comment it out. Whoops, I'm going to comment it out because if I wrote it in there, I'd have two getters. But many people will write it like this. They'll say get. Like that. Now, why did I write it the way I wrote it? Not the commented out way, but the other way. Why did I write it like this? And the answer is, it's a shortcut, and it's less typing. And a lot of times when people have been doing this for a while, you know, I've never met a person who got into programming because they liked typing, for example. All right, so this does the same thing as this. Now, I'm going to come in here and write another comment. All right, I'm going to write, this is a setter with no validation. It just takes it. So what if I passed in there, for example, what if I passed in there nothing, no name? It would take it. All right, so I am going to put in some validation. So I'm going to say set, and I'll say if string dot is null or white space, we'll use that one, value. So that's saying if it's empty, we will throw a new argument exception. That's what I wanted. And that'll be it. So we'll say you must provide a first name. Okay? So if I leave it blank, it won't accept it. It'll throw a new argument, exception, but if I get down to here, something was entered. Now I could enter 1, 2, 3 for the name. So we could check to make sure it's all alpha, etc. I'm not going to do all that. I'm just going to leave it like that. Now when you think about it, this is the first name, and we want to do, not basically, we want to do the same thing for the last name. So normally I would take the time and I would go and key all this stuff in. All right, so we've got it in there once. Let's put it in there again. It's going to give me errors probably because I've already got one called first name. So let's call this one last name. All right, so again, I'll leave all this stuff in there just so you see it. You stop so you don't hear the clock. All right, so continuing on, we're doing the exact same thing, and I'm being a little lazy here, I admit it. So in both cases, now this is last name. We could write it with a shortcut, but I'm just going to use the getter. We have a setter with no validation, so that'll say last name equal value, or we can do some validation. All right, so this will be a setter with validation. And we'll put that up above as well. All right, so if we leave it blank, we say you must provide a last name, etc. So that'll handle 2 of our 4 fields. All right, now for the gender, let's keep it simple. We can add to it later, but let's keep it simple, and let's say that the gender can't be empty either. So we will copy everything we just did here for the last name. And that's going to now be gender. So this again is going to be gender. So is this. So is this. And this. Now we can add more onto this too. All right. So for example, all right, where we say here you must provide a gender, we could say here as an example, let's see, let the user know that they're expecting M or F, okay, as an example. So we've got this. So if you left it blank, we could also check if value, so if it gets down to here, we put in something. So a value dot toUpper is not equal to, doesn't seem to like this, but we'll see, M, or value dot toUpper is not equal to F. All right, now we don't want to throw an argument null exception. We'll just throw an argument exception. All right, and we'll just say gender must be M or F. Okay, if we get down to here, we put in an M or an F. So it's all cool. All right, finally we've got age. Let's rewrite that one from the start ourselves. All right, so we'll say public int age. All right. Again, we can do a shortcut just like we've been doing. I'm going to grab all this. It's going to look a little funky, but because I'm going to have to make some changes. But we can put this in here with no validation and say age. Oops, that's the wrong one. I'm sorry. Let me get rid of all this. Right here. All right. All right. So we can come in here and say get age, or we can just return age. All right. But in our setter, again, we could say do it with no validation. But I mean, what if somebody put in something, a value that, let's even say it was an integer. All right. But we put in an integer, a negative number or a real high number like 10,000 or something like that. So we could say here if value is less than 0 or value is greater than, let's say, 125. I don't think that anybody lives any longer than that. We can throw a new argument exception and say age must be between 0 and 125. If we get down to here, we have put in a valid value, so we can say age equal value. Hopefully you kind of see the pattern that's emerging here. All right, and when you refer to these fields in the get, when you're creating them, you use a capital letter like this. So we now have everything, as far as I can tell, everything that we were supposed to do as far as coming in here and doing, setting up our class. Okay, so we've set up the getters and setters for all 4 fields. Now, are we missing anything? Well, right now it's not doing anything. All right, so let's also come in here, and after the gender and the age, so after all that stuff, let's put in a constructor. A constructor is a method that is called when you create an instance of a class. If you don't create your own constructor, one is created for you, but it does basically nothing. Here we want it to do something. So it's our constructor. We're going to say public person. We're expecting there to be a string for the first name, a string for the last name, a string for the gender, and an integer for the age. All right, and we're going to say that first name equals first name, that last name equals last name, the gender is gender, and the age is age. Now, you don't have to do this, but because I'm a little quirky about this stuff, as you know, I'm just going to line it up. All right. Now, am I done? The answer is almost, but I'm going to override a method, one more method. This is overriding. There is a built-in method that you always get that's called a toString method. I'm going to override that toString method because if I don't, it's not going to really do very much. And if it does print out something, it won't look the way I want it to look. So I'm going to override the toString method. So I'm going to say public. I have to let it know I'm overriding. override string to string. So when I create this, when I create this now, and I have it come and print out whatever it is I want it to print out, okay, now I'm in control. So I'm going to do this. I'm going to say return. We'll use our old friend here, the $sign, and we'll put in here how about this? Name, first name with a space, last name. Oops, I don't need that. There we go. We're not done yet. Yeah, I can do it just like this. I don't want to use the IntelliSense now. Fine. I'll use the IntelliSense, but I'm going to kind of rewrite it as we go here. So I want that. Then on a new line, I'm going to want it to say gender, not genetter, gender, followed by the gender. And then another new line. Whoops, another new line. And then age, followed by the age. Whoops. All right. Now, did I have to do all that stuff? The answer is no, I did not. All right. But doing what I did, now what I've done in here is I've created a brand new class. Notice I'm not using any of these, so they can all be removed. I can leave them in there, it doesn't hurt a thing. My namespace is people, my class is person. Each person has a first name, a last name, a gender, and an age. They're all created as fields, but they're all private. All right, then we went in and we created our methods. When the methods are dealing directly like these are with these class private fields, they're known as properties. So I've got my first name property, and I showed one way of writing it, and then another way of writing a getter, and then the way I'm doing it, a way of writing a setter with no validation and then with validation. Then did the same thing for the last name. Then did the same thing for the gender. Put a little more in here because I said the gender must be M or F, so the person knows. And an age, which has to fall within a certain range. Finally, we came in here and we created, excuse me, we created a constructor where we're going to be copying all the fields in, and we overrode this toString method, so this is what should print out. So if I entered my name and I did everything the way it should be done, it would come back name, colon, space, Jeff, space, Scott. Then on a new line, gender, colon, space, M. Then on another new line, age, colon, space, 69. Hopefully all that makes sense. All right, I'm already in here, whoops. I am already in here up to 34 minutes. So I'm going to stop, and in the next lecture, I'm going to do two things. First, I'm going to finish this, and there's not a lot more to do, but I do want to explain what I'm doing as I'm doing it. All right, then we'll start to write a second version of this as well. So I'll be back to do that in just a couple moments.